Okay, indices question is worth always knowing your indices. There's always a question on these coming up, and they're quite straightforward, really. But they also bleed into, I say bleed, they also affect knowing how to do other questions. If you can't do your indices, you'll struggle in other aspects. So it's worth knowing these and practicing these as often as you can. Okay, so I'm just going to start over here with a few kind of basic indices rules. Okay, so say we said I've got a squared times by a cubed. Okay, a lot of people would say, oh, a to the 6 because it's times. But that's not correct. Okay, we're adding indices when we multiply them. Okay, so that would give us 5. All right, when we divide, we just take away. Okay, a3 over a2, that would give us a1. Okay, so multiply and divide are the same but opposite. So it makes sense if we're kind of adding for the multiplying, we're taking away for the dividing. Okay, so think if you're not sure, if you forget, if you think, do I multiply, do I add, what do I do? Try and think, what do you do when you divide, then do the opposite. Okay, but I think the divide one's easier to get your head around because, well, actually, both of them should be quite straightforward because for the multiplication, a squared is just a. If you times that by a cubed, that's a. So that's just a. So it's 5 a's. So it shouldn't be that hard actually to kind of think to yourself, well, what am I doing? All right. The one that you do multiply is when you've got powers. So if you've got a cubed squared, that's going to give you a to the 6. Okay. So if you think what a cubed is, a times a, and then square it, you're going to times it by itself, a times a times a. So you're back to the beginning again of a times a times a times a times a times a, 6 a's. All right. So that's our three main rules. The trickier rules, which we're using here, is when we get into the fractions. Okay, so we've got 1 over a to the x. That's the same as a to the minus x. Okay, so 1 over a to the 5 is equal to a to the minus 5. Okay, that's something that people aren't amazing with. And the only other rule that kind of comes up, apart from what we're just about to do, a to the 0 is 1. Okay, so n to the power of 0 is 1. Okay, 5 to the power of 0, 1. 6 to the power of 0, 1. Okay, so try and remember these. They do come up a lot, and they're really not that hard to remember. I'd say this one is probably the one that people forget and struggle with. Okay, so yeah, but yeah, the one we're using here is our surd rule. Okay, sorry, our fractions rule. So if we've got a to the 3 over 2, that's the same as the square root of a cubed. Okay, if we've got a to the 5 over 6, that's the same as the 6 root a to the 5. Okay, so we move this. I don't know why I say move, but Scottish, so that cows. We move the 6 over here. Okay, the downstairs moves, the top stays the same. Okay, so that's the rule we're going to apply here to start off with. So 1 over x, and that's like x to the 1, isn't it? We just don't show the 1, but it is there. Okay, so that's the same as 1 over x to the third. Okay, now we said before that 1 over something is the same as the negative, okay, on top. So we can then rewrite that as x to the minus third by moving it up. Okay, good. Now you can almost recognize that if the more we practice these, you might even be able to look at that and just say, well, I know that. Yep, that's fine. Because they do pop up quite a lot actually. The same kind of questions. Okay. I think that's actually everything on that section. All right. So you get a mark for understanding the fraction, and then another red pen, please. One pen for Shirley. There we go. And then another mark for your negative. Okay. Time, good time. Here we go. Okay, so we're getting towards the end of the paper now. Okay, we've got 3 questions left, and this is when they will start to throw some trickier questions your way. All right. Yeah, indices was quite straightforward. Equation of a straight line isn't that difficult. I think sine rule is very straightforward. Factorizing is a bit trickier. I think there's a wee bit in factorizing, and it is worth practicing. The vectors question there wasn't that hard. I don't think they gives any mental. Converse Pythagoras, very straightforward. The volume question, for 5 marks, volume of spheres. I mean, that's brilliant. That's fantastic. There was 2 questions on percentages, which again, there's not a huge amount in percentages. We explained how to kind of spot this question because it does look like a tricky question, but actually we're just again subbing into an equation. Cosine rule, again subbing into an equation, back to our percentages we said, and then the magnitude question seems to be hidden on my screen. I don't know if you can see that here. So actually, there's been a lot of, I would say, very easy questions. A little bit of problem solving here with the spheres, okay, a tiny bit of problem solving, and sometimes they were thrown in little twists. When we looked at say the angles here just to get you started, okay. Maybe rearranging this in such a funny way meant the straight line question was a little, again, a slight twist. But that's all they can do. There's only so much they can ask you, and they'll try and put a little twist in it. But I'd say so far, there's not really been a huge amount of problem solving, and the last few questions usually start to test that. That's my experience doing these videos anyway. Okay. So here we go. Two identical shapes form a logo. So don't know the logo for this. This is like a bike shop or something. I don't know, it's cogs in a machine, or I don't know. So the circles with center C1 and C2. Okay, we can see that. The radius of each of the circles is 14. That's an interesting thing to point. So I'm just going to write that in. I'm going to say, just on here, I'm going to say radius is 14. Radius is 14. Pen. Okay. There's a half turn of symmetry about the midpoint. Okay, so basically they're saying it's the same shape. Okay. And AB is 48 long. Okay, so I know that the length from, where am I going to write this? I'll write it up here, okay. 48 is the distance from here to here, A to B. Calculate the height of the logo. So I said this in the last video. Whenever you see circles that are chopped up, and again, if you give this to any adult who's not been doing their National 5, I would suggest most adults wouldn't get this. Okay, I think some of the other questions people might get, but I think the problem solving element here would make people think, wait a minute, how do you do that? Okay, but we should have been training ourselves, and we should have been going through the syllabus, and we should know when we see a circle that's chopped in half like this. Oops, computer's not happy with that. When we see a question that's chopped in half like this, we know it's going to be a Pythagoras question. Okay, so when we've got circles with a line through them, Pythagoras. Now what we're trying to find is a right angled triangle. Okay, that's the key. Right. So just to get started off though, the height here, yeah, it's going to be from this bit to this bit. That's a radius, isn't it? And then from this bit to this bit is a radius. Okay, from C up to the top is a radius, which is that part of the height. And then from C to that's a radius. So we're just trying to find this middle section in here. This is the bit that we don't know. Okay, and this is where our right angle triangles come in. Okay, so when you see these, like right angle triangle, and then like, well, where is my right angle triangle? Well, I know this height up here, I know this height here, so it's got to be in the middle somewhere. Okay, now I'm just going to look at this. I'll just look at this circle here because they're both the same, doesn't matter. I could draw this. Okay, now what have I just drawn there? I've just drawn two radiuses, yeah. It's the same on this. If these were two different circles, you'd have to do this all twice, but we don't, okay? They're just radiuses. Okay, radius goes from the center to the edge. Okay, so that's a good start. And I'm trying to find the height though. Okay, I'm trying to find this height here. Now I know this height is going to be the same, so if we were to say from here to here is x, then I know that this bit in here is going to be 2x. Yeah, because it's going from the center to the line, and then from the line down again. Okay, so that's x and that's x. Okay, so it's already starting to look like we know bits and pieces, don't we? So let's draw a right angle triangle out, and I'm going to draw, like I said, I'll just look at this part of the diagram. Okay. I know that's a right angle in there because I'm going to draw. I've drawn a vertical line to the middle of this point. Okay, if I draw a vertical line, it meets at perpendicular at right angles because they're perpendicular, and it joins in the middle. Okay, so that's what I've just drawn here. I know this is the radius because the radius goes from the center to the edge of the circumference. But what I should also be able to work out is this value in here. Now, from A to B is 48. So that means that half of that would be 24, would be the distance from the center. That distance in there, yeah, that'd be 24. So that means on my diagram, we're going to half that again, and we're going to get 12. Okay, so I'm trying to find x, I know that's 12, and I actually do know the radius, which we said was 14. I'll just scrub that out. Oh, actually, I'll just say r is equal to 14. Okay, so we're trying to find a short side, so we're going to do Pythagoras add, or we're going to do Pythagoras take away. We're going to do Pythagoras take away. So just to remind people, again, I'm sorry if loads of this is repeated because the videos do have the same kind of questions. A, B, C, Pythagoras is obviously A squared plus B squared is equal to C squared. Okay. The hypotenuse is always opposite right angle. Okay. That's your hypotenuse. Either side could be A or B. Okay. So if we're trying to find the hypotenuse, we would do Pythagoras add, which is to say we're going to add the squares of the two short sides. If we're trying to find the short side, we would do C squared minus A squared is equal to B squared. Okay. So we do the square of hypotenuse take away the square of one of the short sides equals the square of the other short side. Okay. So that's going to give me 14 squared take away 12 squared square root is equal to x. Okay, so I've just moved that square sign over here to give us the value on its own. Okay, so 14 squared is 160. Let's say 169, 164, 196. I'll say that can be 196 minus 144 square root. So that's going to give us it's going to give us 7.211. And we're in centimeters. Okay. Now that's great. We've worked out a triangle. Okay, and like I said, whenever you see these circles, always be thinking of the triangle. We've solved for the height of the triangle, but we're not quite finished. We need the height of the logo. Now I just said the height of the logo was 2r and 2x. Okay, so just all the sentence at the bottom, logo equals 2x plus 2r. So that's going to give us 2 times 7.211. So that's 14.42. Obviously it was 42. Plus 2 times r was 14, so that's 28. So that number plus 28 is going to give me 42.422, and that is in, just the way I've written it, I should really just leave that out, centimeters. Okay, I'm running out of time, so I'll just be quick with the marks. So you get a mark for identifying your triangle, good stuff. You get a mark for knowing your Pythagoras. You get a mark for working out the value of x. And then to actually find the height, you get another mark. Okay, so as I said, getting towards the end of the paper, they're going to get a little bit trickier. I think when you see that done, there's really not a lot to it. But if you've not practiced, or if you gave that to an adult, I think actually you'd be saying, no idea. Okay, when you see circles that are chopped in half, you're always trying to find this right angle triangle. Okay, so make sure you draw this out, and then we're just trying to find one of the unknown lengths. One of them is going to be the radius. One of them will be given to you in a strange way. We had to half 48 and then half it again. Okay, and then answer the question. Okay, and again, some people might not realize to add 2 radiuses to it, or they might just think the height is this value we've worked out. Okay, make sure you answer the question. All right, so good stuff on that. Nice.